An organic molecule gives the following mass spectrum and infrared spectrum. Identify the molecule that best correlates with these spectra. So these are both data collected from the same compound, and it's one of these four structures. So immediately what I notice is this particular pattern in the mass spec where I'm seeing a series of peaks where I've got one taller peak and 2 mass units heavier, about 1/3 the height, I have another peak. So this is most likely a pattern where this is my molecular ion, and this is what we would call the M+2 peak. So this pattern is indicative of having an M+ peak and a prominent peak 2 mass units heavier is indicative of a molecule that contains a halogen. And the fact that this is approximately 1/3 the height tells me that we have a chlorine present. And so what we're seeing through the mass spectrum is that every fragment that still contains the chlorine has that same pattern. So that tells me that this molecule contains chlorine. So we're looking at either C or D. So at this point, we could solve this problem simply by adding up the mass of C and D, because we can see hopefully they don't have the same molecular formula. I can see 6 carbon atoms, 7, so 7 carbon atoms total in C, 6, 7, 8 total in D. These are definitely going to have different masses. So only one of these is going to weigh 154. If I know some characteristics though from the infrared spectrum, I can very, very quickly identify which is which. So in your infrared spectrum, you have 3 general regions, and you can subdivide these further, but you can typically see your bonds to hydrogen. You can see triple bonds if you have any. And you can see double bonds. And so in the bonds to hydrogen for C, one thing that stands out to me is this OH. And this alcohol group. And so in this top region of the spectrum where we tend to see our bonds to hydrogen, which tend to be in this area, so bonds to H, if we had an alcohol, we would see this intense rounded alcohol peak. So I noticed that there is no peak for that. So that leads me to think that it's not C. Okay, what I am seeing in the bonds to hydrogen is 2 different types of carbon-hydrogen stretches. So I'm seeing these peaks that are just above 3,000. That is characteristics of carbon-hydrogens that are sp2 hybridized carbons. And then I also see just below 3,000 another little cluster of peaks, and this is characteristic of carbon-hydrogens on sp3 hybridized carbons. And I would expect to see these 2 types of stretches for either of these molecules. But really not seeing that OH really makes me think that it's not C. Triple bonds, there's no triple bonds that would differentiate these. Double bonds. So I noticed that D has a carbon-oxygen double bond. And this is usually a very intense peak, usually very prominent, and we can see it right here. That's the carbonyl. So very intense. They're usually centered around 1700, give or take. So that really makes me think it's D. And if we wanted to confirm, we could add up the mass and find out that yes, it does indeed weigh 154.